Hello dear students, this is Srimati Ashwini S, Assistant Professor of Mathematics working at SSS GFGC Moodalgi. The topic which we are going to discuss today is from Unit 4 Sequences 1 Introduction. Let's see what a sequence is. In mathematics, a sequence is nothing but an ordered collection of objects in which repetitions are allowed. You know, when a sequence is given, there are many elements. So the number of elements which is given in a sequence is called the length of a sequence. Now let's see what exactly is a definition of sequence mathematically. Okay. So a sequence is defined to be a mapping F from the set of all natural numbers capital N to a set capital S. Which means to say we are going to consider a function F and there would be a mapping from capital N to capital S, where capital N is nothing but the set of natural numbers and capital S is going to be a set. When we write this mapping, it is known as a sequence. Now let's consider a few examples. The first example which I have considered is, you know, there are numbers 1, 4, 7, 10, 13 and so on. You know, this is in a particular sequence wherein the difference between each number is 3. So this can be taken as an example for a sequence. The second problem is we have considered the set of all even numbers starting from 2. So you can write it as 2, 4, 6, 8 and so on. Let me take the other one. So here you have 1, 4, 9, 16, 25 and so on. Can you all guess what this is? Yes, right. These are nothing but square of a number. 1, 4 is nothing but 2 square, 9 is nothing but 3 square, 16 is nothing but 4 square, 25 is 5 square. So obviously the next number would be 36, which is 6 square. So there is a particular rule in which a formation of numbers are being formed. So such kind of rules or formations can be taken as examples for a sequence. Now let's see what a real sequence is. A real sequence is a function whose domain is the set n of all natural numbers and range is a subset of the set capital R of real numbers. Symbolically, there will be a mapping F from n to R, which would be a real sequence. Here, your domain is capital N and your range is nothing but capital R. N is set of natural numbers, R is set of real numbers. Now let's see how the elements are represented here. The elements are given by A1, A2, A3, A4 and so on. All these letters are written in small letters. So we denote your sequence by either a flower bracket or within 2 less than greater than symbol. So it is denoted by AN and your elements are represented by A1, A2, A3, A4 and so on, AN and so on, where your A1 is nothing but the first term of a sequence, A2 is the second term of the sequence, A3 is the third term. Suppose I say A10, it would be the 10th term. When I say AN, it would be the nth term. Now let's see what is range of a sequence. The set of all distinct terms of a sequence is called range, which means to say a finite number of elements in a given sequence is called a range. So in a sequence AN, since n belongs to capital N, that is all the elements small n belongs to natural numbers, and you know natural number is an infinite set, the number of terms of a sequence is always infinite. So when you take a sequence, there are going to be infinite number of terms, but when we consider range of a sequence, that is always a finite set. Now let's take an example. Here a sequence AN is given as -1 to the power of n. So let's see what are the terms of a sequence here. Let me consider n as even and n as odd. When I consider n as odd, that is, if I put n is equal to 1, you know -1 whole power 1 is -1. Next number, I'm going to put n is equal to 2, which is an even number, and we all know -1 whole square is going to be +1. Next what I do is I put n is equal to 3. So -1 whole cube is again -1. When I put n is equal to 4, I get -1 whole power 4 is equal to +1. So there is an alternative sequence of -1 +1 -1 +1. Though the entire sequence is an infinite term, we have only two values. What are those two values? It is either -1 or +1. Therefore, the range of the sequence an is equal to -1, 1, which is definitely a finite set. So what do you understand from this is, there can be infinite number of terms in a sequence, but when it comes to a range, it is always going to be a finite set, or finite number of terms will be there. Now let's see what is a constant sequence. A sequence an defined by an is equal to c, where the c belongs to a real numbers r for all n belongs to n, is called a constant sequence. Thus, that is, which means to say we would be getting one element for the entire terms of the sequence. Therefore, sequence an is given by c, c, and so on. This is a constant sequence. When I have to find the range, there are a lot of repetitions. I would be considering a single element. So I say range is equal to c. And if a set contains only one element, it is known as a singleton set. Therefore, range is equal to c, a singleton. So next definition would be limit of a sequence. This we have already studied it, so let's just recall them. A sequence an is said to tend to a finite limit L as n tends to infinity if, given epsilon greater than 0, however small, there exists a positive integer m such that modulus of an minus L is less than epsilon for all n greater than or equal to m. This is our epsilon definition of a limit. So this is denoted as an tends to L as n tends to infinity. This can also be written as limit n tends to infinity an is equal to L if modulus of an minus L is less than epsilon for all n greater than or equal to m. We all know when a modulus sign is removed, we have to write a minus sign and a plus sign towards the left hand side and right hand side. So when I do that, the definition can also be limit an is equal to L if L minus epsilon is less than an is less than L plus epsilon. So the references which I have used are Sequences and Infinite Series by N.P. Bali and a textbook of college mathematics by G.K. Ranganath. Thank you.